Hey guys, IE.RVT here, and we're looking at Module 5, Homework B, Tab 1, Part 2, Series Capacitors-Charge. So from what we already know, we know that from definition of capacitance, we have Q is equal to C times V, where Q is the charge stored, C is the capacitance, and V is the voltage across the capacitor. For the entire series combination, the total charge Q of T is stored on the equivalent capacitor C of T is related to the total voltage V applied to the battery, which we get Q of T is equal to C of T times V. Now in the previous part, we already found C of T, so we're going to go ahead and rewrite that out. So C of T was equal to 1 all divided by 1 over C1 plus 1 over C2 plus 1 over C3. And we can go ahead and substitute this into the expression for Q of T. So now we have Q of T is equal to, Q sub T, is equal to V all divided by 1 over C1 plus 1 over C2 plus 1 over C3. And this is charge stored on the total equivalence capacity C of T. And that's pretty much going to be our final answer that you should be putting into Snape physics. In a series capacitor circuit, all the capacitors share the same charge Q of T. The total charge on the equivalent capacitance is the same as the charge on each individual capacitor, and the voltage V applied to the battery is divided across the capacitors. The total capacitance C of T is C sub capital T is less than any of the individual capacitances because the capacitors in series act like resistors in parallel. The smaller the total capacitance, the larger the total Q sub T will be, given a fixed voltage V.